So this is a video lesson on Note 6.6. We're going to use proportions of similar triangles. Through this lesson, we'll talk about different properties or theorems that are proven true. We'll use proportions of triangles with parallel lines, also with angle bisectors, to solve missing side lengths. So we're going to use different pieces we know about right triangles or triangles to find missing parts. So let's go ahead and look at our first theorem here. The triangle proportionality theorem. If a line is parallel to one side, the line is parallel to one side of a triangle, intersects the other two sides, then it's divided into two sides that are proportional. So if I know that this line QS is parallel to TU, kind of stated right here, then I know that the sides RT has, and over TQ, those two sides have the same ratio as RU over US. So because of that proportion and because of the parallel lines, I can find those side lengths depending on what I'm trying to find. The converse of this postulate is also true. So when I'm talking about the converse, I'm switching the if and the then part. So now if a line is divided into two sides that are proportional, then those lines have to be parallel. The third sides have to be parallel. So once I know that this side with this side is proportional to this side and this side, then I can state that QS is parallel to TU. So we're going to practice this and find different side lengths or determine whether the lines are parallel. Here in the first practice problem, in the diagram, they tell me that QS is parallel to UT, and that's marked here in my picture with those little arrows. So if those two sides are parallel, and they also tell me the length of two segments, they tell me that RS is 4 and ST is 6, I can see that these two sides are on the same side, and by my proportionality theorem above here for triangles, I know that those two sides set up a ratio, 4 over 6. That would be congruent to the ratio of the two other sides that are opposite of those two sides along my parallel lines. So here then I can say that QR, or RQ, matches 4 right across the side here, and here 9 and 6 match up, so I can write a 9 in for that space for QU. So since I know 3 of the segments, I need to find the third. I can just use my cross product property and get 4 times 9 is 36, and 6 times the length of RQ. So then when I divide by 6, RQ has a length of 6. Here, number 2, I'm going to go ahead and determine if these are parallel. So by using the converse, if the sides are proportional, then I know that then those two sides, PS and QR, would be parallel to each other. I can only determine that if my sides are proportional. So when I set up my ratio, I'm going to start with N, and I'm going to go to Q, and I'm going to use those two side lengths as my first proportion. So this is going to be maybe 90 over 50. Since I'm going 90 over 50, I have to make sure that I use the matching side up top. So 90 over, and then this would be 72. And here 50 would go with 40. And those kind of match up. It's always about recognizing patterns and recognizing which piece goes with which piece. So if these two ratios are equivalent to each other, then I know that the lines are parallel to each other. And they don't look like it right now, but if I would go ahead and simplify these, obviously this, if I take out a 10 and a 10, here I have 9 over 5, and here, if I look for a common factor where I reduce it down, here I would go ahead and take an 8 out of this, so this would become 9, take an 8 out of 40, and that becomes 5. So this also has a ratio of 9/5. So since those ratios are the same, then I know that PS would have to be parallel to QR. So yes, PS is parallel to QR because the sides are proportional. How do I know they're proportional? Well, they have the exact same scale factor. Go ahead and try the next problem on your own. I'm going to fill in the space here and kind of give you some feedback on that, but go ahead and try this problem, and then we'll go over the next one together. So go ahead and just pause the video and give it your best shot. Remember, following your theorem and following your practice from the previous problem, number 1, you should be able to find the missing side length. So what do they want us to find? They want us to find zy. So that's the side I'm trying to missing or I'm finding. So I'm going to set up that ratio on the same line. So here I have my proportion, my first ratio, I don't know zy, all over 36. And if I follow the line respectively on the other side, then I'm going to get a 35 over 44. Sometimes it's easier to reduce with these large numbers. It might be easier to reduce your fraction first before simplifying and solving for zy, the length of zy. So here, when I look at 35, sorry, I should change that. Make sure you change this in your notes. This 44 should really be a 45 to make it work. So we got to make this a 45 value. So make sure you change that in your notes. So 35 over 45, yeah, that simplifies pretty easily. If I take out a scale factor of, if I take out a common factor of 5, all I'm left with is a 7 over 9. Now, if I'm trying to find zy, it might be easier to multiply that smaller number by 36. So 7 times 36 is going to give me 252, and that's equal to 9 times zy. Divide by 9, and zy is equal to 28 units. Okay. So again, that's problems for you to try on your own. Make sure you follow the steps and rewind the video if you get stuck or don't feel like you understand how I set up the proportion. That might be able to help you as well. Look at the next page. We do have 2 more theorems here to kind of talk about, and then we have some mixed practice for you to try after that. So here in this theorem, if 3 lines are parallel are intersected by 2 transversals. So if 3 lines are parallel, my 3 lines that I'm talking about are parallel here are R, S, and T. So those are my parallel lines, and they're cut by 2 transversals. So here, line L is my transversal, and line M is my transversal. So if that's the case, then they divide the transversal, and they make set up a proportion along those transversals. So along the transversal line, here I have UW, which is right here, and over YW along the same transversal line, and that proportion would be that ratio would be equal to VX over XZ. Here also, because of a bisecting theorem, here I have a ray that bisects an angle. So here I have a ray starting at C and going through D. This ray, CD, it bisects the angle ACB. So when you bisect an angle, it makes those 2 smaller angles congruent to each other. So this little angle, ACD, is congruent to DCB. So since those angles are congruent, I know that CD is a bisector. Then it divides the opposite sides of the segment into something that's proportional. So here, let's follow our ratio here. I have an AD over DB. So when I look for those segments, AD over DB, these 2 segments would be their ratio would be equivalent to the ratio of CA over CB. And you can kind of see along the green line here, we kind of go from AD and CA, if you look at the top, AD and CA, AD and CA, that's these 2 sides together. And if I look at the bottom, DB and CB, those 2 sides on the same side of the green line. So if I'm looking at this rule, I got to make sure that I match up those sides appropriately based on the bisecting ray. So here, they want me to find the length of AB. And I can see that I have 2 transversals, right here and right here. And I have 3 parallel lines. Now how do I know these lines are parallel? Well, when I look at these lines, they form right angles with this bottom transversal. So since these are 3 right angles, then I know those are corresponding angles that are congruent, which makes these green lines parallel to each other. So if they're parallel to each other, then if I have another transversal, they would also be cutting through there and making those angles congruent as well. So if I'm trying to find AB, I want to set up the ratio along the same transversal. So along the first transversal I have 16 and I have question mark, AB, so I have 16 over AB. Here, on the second transversal, going from the same direction, 15 over 18. So again, when solving this problem, it might be easier to simplify your ratio first, or not, just cross multiply, that's fine. But 15 over 18 have a common factor of 3. So I can take out a 3 out of the top and get 5 over 6. Now when I cross multiply and divide, I end up getting a 5x, or 5 times AB, is equal to 16 times 6, which is equal to 96. And when I divide by 5, since 96 doesn't end in a 5 or 0, I'm going to get a decimal here, and the length of AB is equal to 19.2. So looking at number 4 here, we're trying to find the length of AB. Again, AB is right here. But here I have a different type of problem. It looks like our second theorem, which talked about a ray, BD, which it bisected the angle and made 2 smaller congruent angles. So when I bisect that angle, it breaks my triangle into 2 smaller triangles that I can set a proportion up in. So here I have one proportion is equal to another. Specifically, I can look at side AB goes along with the side AB, and it kind of matches with the side that's on the other side, BC 30. Now remember, once I went across AB, I have to follow that line around A to find my other piece here up top, which would be 52. And then here 30 would go to 20. So there's my proportion that I set up. And then I'm going to cross multiply. Again, 52 and 20 is a relatively large factor, so it might be easier to take out a common factor than the share. Since they're both even, I can take out a 2. So, or I could take out a 4, because both of those numbers go into it. So when I divide 52 by 4, I get 13. When I divide 20 by 4, I get 5. So here it might be a little easier to cross multiply and figure out a smaller value for that. So when I cross multiply and I multiply 30 times 13, I end up with 390. And that's equal to AB times 5, or 5 times AB. Divide 390 by 5, and the length of AB should be equal to 78. So we're going to try some more practice problems here. Again, feel free at any moment during the video to kind of just pause the video, try a problem, then re-watch the video and kind of watch me walk through it and see if you set the right proportion, and then see if you solve correctly. Again, the only way you really get better at this is if you practice individually, but here you have some guided practice with me as well. So first of all, when I look at number 5, I do see I have parallel lines. So with those parallel lines, the sides adjacent to those parallel lines are going to set up a lovely proportion here that I could solve for. So here, if I look at my blue and my purple, my ratio is going to look like a 12 over 36 since they fall in the same line. And that's going to be equivalent to 9 over x. So when I cross multiply, or maybe I simplify first, 12 and 36, 12 goes into 36 3 times. So now when I cross multiply, I get x is equal to the product of 3 and 9, which is 27. Number 6, I can see that I have 2 congruent angles, so this must be a bisecting line. So when I look at that bisection here, now I can kind of set up my proportion. And along, kind of reflected across that line, if 16's here, that's going to kind of match with x. So 16 over x. And going side to side, 16 is going to be paired up with 8. So 16, 8, and then x in 10. Once I cross multiply, and again, 8 over 10, I can simplify that first. They both share a factor of 2. So this is going to be a 4 over 5. Whatever 16 times 5 is, which is 80, and then 4x. So I have 4x is equal to 80, and when I divide by 4, I end up with x being equal to whatever 80 divided by 4 is, which is 20. And boxing or circling the final answer. Number 7, Similar, right? I see some parallel lines here. I'm going to mark those with the green. Parallel, 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 parallel. And I have two transversals that cut through them. So along the transversal lines are where my proportion is going to be set up. So here, on this this transversal, I end up with a 28 and an 8. So I'm going to have a 28 over 8, or an 8 over 28, depending on which way you go. On the other side here, going from top to bottom, I have x over 12. So here, again, when I'm solving for x, I always try to simplify if possible. When I look at 28 over 8, I can see that they share a common factor of 4. And 4 times what gives me 28? Well, that'd be 7. And when I divide 8 by 4, I get 2. So now if I cross multiply, 7 times 12, it's going to give me 7 times 12. It's going to give me a value here. Really, I can just leave that as a product, so I have 2x is equal to 7 times 12. If you ever try to do this, this is kind of a different way of solving. Since I'm going to divide by 2, I can then always divide, since it's a product, I can divide 12 by 2, which is going to give me 12 divided by 2 is a 6, and what's 7 times 6? 42. Meaning that x is equal to 42. Little mental math trick there for you. Look at number 8 now. Oof. Got lots of parallel lines here. Gotta want to make sure I identify which sides are going to match up with which sides. So here are my 4 parallel lines, and obviously then the lines on the outside, they would also be transversals that cut through those parallel lines, meaning that the corresponding angles are going to be congruent. So when I look at this problem, I want to make sure that I kind of have to solve for each of my variables, but I'm going to have to set up proportions based on what I'm trying to find here. So when I look at this problem, it's kind of combining what we did with 7 and what we did with number 5, but we're just going to kind of set up proportions that are equivalent and kind of go from there. So when I look at these different triangles, I have lots of different problems. I'm trying to solve for A, I'm trying to solve for B, looks like I'm trying to solve for C, D, E, and F. So I have 1, 2, 3, 4, 5, 6 variables to solve for here. When I'm setting up my proportions, I want to try to find as many of the segment lengths as possible and kind of plug in what I know and use that moving forward. So here, if I'm looking at my first proportion, let's say I'm solving for like A side goes right here. And if I look at A looks to be a part of the big triangle. And to find the big triangle, what I'm going to need is I'm going to need the entire side lengths here for this and this. However, since I don't have E, F, or B, it's really tough for me to find A right away. So rather than using that, let's go ahead and jump to a smaller problem that I might know and solve for those values as well. So the first thing I might want to look for or solve for is looking for one variable where I know the 3 other sides. Here are E, here's 5, here's 15, and here's 12. This is kind of like our problem with our 3 parallel lines, these 3 parallel lines and the true transversals. So I can set up a proportion where E over 12 is equal to 5 over 15. So 5 over 15 can be reduced to 1 over 3. And when I cross multiply and then I do 3E equals 12, I know that E has to be equal to 4. And I'm going to go ahead and plug in that value there, so I found one of my side lengths. Now I need to try to find another side length that I can find based off those 2 triangles. It'd be really great if I could kind of jump around and find something that would also be congruent. If I look at F is another one that might be easy to find. Here's F, opposite of F is 10. Next to 10 is 15, and here's 12. So here I have kind of the 4 blue ones, and they kind of match up with what we did in number 5, right? If I set up a proportion where along this line I have F and 12, and along the other line I have 10 and 15, I can set up that same type of proportion and solve. When I cross multiply, actually before I do that I might want to take out a common factor of 5 here, get 2/3. cross multiply gives me 24 is equal to 3f, and when I divide by 3, f is going to be equal to 8. So here I know f is equal to 8, which is great because now this entire red line, this transversal, I have all 4 side lengths. The only thing I'm missing now is B, C, and D, obviously. So let's go ahead and set up another proportion here, maybe moving through to find D next. D is this little triangle right here. So this triangle has a D over 10. I can kind of see that those two sides go with each other. And since that triangle is going to be similar to this triangle by angle, D over 10 is going to be equal to the side matches that, so it'll be 12.5 over the side length that matches 10, which is really 15 and 10 added together. So when I add those, I get 25. Now when I cross multiply, lots of different ways you could do it, but when I cross multiply and divide here, I'm going to get a value for D. Not a hard one to cross multiply for. You get 25D when I cross product that way. 12.5 times 10 just moves the decimal place, so that's really 125. And when I figure out how many quarters are in $1.25, I realize that I end up with B equaling 5. Oh, sorry, not B, D. D equals 5. So now I found this piece right here, that's 5. So I'm moving right along here. Next thing I might want to find is either C or maybe even B. You can really kind of pick and choose which battles you want to fight first. I might want to find B because it's then I found all the ones on the outside. So if I'm solving this proportion now, B is sitting right here. And B along the same side is like, for example, 5. So we can kind of go B over 5. And if I go across the other red line, that's like 12.5 over 4. So I'm going to kind of match up those sides, take the cross product, and see what I get from there. B times 4 gives me 4B, and 5 times 12.5 is going to give me 62.5. When I divide that by 4, get a really ugly number here for B. But that's okay. We'll just kind of give it a value as best we can, round to one decimal place. We'll say B is equal to 15.6. Really it's 6.25, but 0.6 would be fine as well. 15.625. So the only pieces we're missing now are A and C. So we're going to keep going through this process and see if we can solve for these last two proportions here. We're going to find A and C kind of like how we found D. We're going to have to set up a proportion based off of a side and a missing side. I have decimals on either side, so it's going to be kind of an ugly process, but you know, we'll kind of piece it together and see what we get. So let's go with red here. C is this value right here. And if I look at C, C matches up with maybe the 5 that I had over here for that similar triangle. So C over 5. And if I look at the little triangle right here, that was 5, 8, and 10. So maybe I use the 8 side right up here. So 5 and 8 kind of match up. And then what side would go with C? So 5 goes with C and 8 goes with 5. Then I'm going to use this segment right here, which would be 20 plus, so that's 24. Because all I'm doing is I'm adding up 4, 12, and 8. When I add those pieces up, I get 24. And that's matching this side with C. And 5 goes with 8. So it's just following that pattern, setting up the right proportion. 24 over 8, that reduces down. That's going to be 1 over 3. And when I cross multiply, C ends up being equal to 15. The only one I'm missing now is letter A. So A is the big one where we have to kind of add up multiple pieces here. So let's set up our last proportion. A corresponds right here. And let's go ahead and use one of our two sides. I like 0.5 more than 6.25, so I'm going to say A is going to match up with the length of this side, which is 12.5 plus 4 plus 12 plus 8, because I got to add up all those little pieces. So when I add up all those pieces, that corresponds with 36.5. That triangle is going to be congruent to any of the other similar triangles that I found along the way. So I could use C, I could use D here, it doesn't really matter. I want to use the smaller triangle because that's the smallest number, so that might be the easiest thing to do. So A matches with 5, and 36.5 matched with 8. So if I do a little cross product here, and I get 36.5 times 5, that gives me 182.5. And then I do 8 times A, it gives me 8A. And then if I divide 182.5 by 8, I get a value for A, and it's not a pretty number, but that's okay. A is going to be equal to 22.8. And we'll kind of round to one decimal place there to give us a pretty good answer. Here, this is a hard problem. This has got multiple proportions that I have to set up. Always going back to either using number 7 with the parallel lines or number 5, the triangles, to set up the right proportions to solve. The next page here for you guys is a bunch of mixed review. So what I'm going to do is I'm going to post the answer key online, not part of this video, but separately. So you can always check those answers and see how you did. Make sure you're trying every problem on your own without your notes. And then if you get stuck, you can always look back at the video or the notes to better understand it. If you come in the morning, come see me. We can kind of talk through it and work on some of the practice problems together.